Well, let's get started. Because there's going to be some concepts I bring up in this session that are going to take some time to go through. And but there's other sections of the presentation that we've covered before, but I'll just reemphasize them here because they're very important in this particular session. So this is session 4. This is the final session of our 4-part series. Sound like a Netflix thing going on here. Limited series. Today's will be, we'll see how we get through it, but probably about an hour long, but I'm mindful of the time that we have here. One of the things that a couple of members have asked is whether or not we can have an in-person follow-up session prior to the potpourri next Friday. So stay tuned for an announcement to be coming out on that. The objective is to have you folks come in with your questions, maybe even bring some of your equipment. We can have a look at it and get some instruction and just a chance to, wrap things up a bit and talk a bit about any kind of customized instruction that we can give. So that'll be probably around 7 p.m. on May 10th in the same room that we're going to be meeting, but I'm just trying to finalize that with Swapna. And so when I have that, I should be able to announce it in a couple of days or so. Okay, so this session is going to be devoted to wide field deep sky astrophotography. So this is going to build upon some of the techniques we talked about in the previous sections, but I'll be covering them as well today and emphasizing certain things. But there's going to be other techniques that are going to be brought up here as well. These 2 photographs are ones that I took myself with just my Canon T3i 200 millimeter focal length f4 ASCAR and Bortle 3 and Bortle 4 skies. So the one on the left is the North America Nebula. I'm sure most of you seen that, in the Pelican. And that was the lens was wide open, 800 ISO. So all these shots are 800 ISO. I didn't go any higher than that because I want the best diametric range as I can get. And 2-minute exposures times 40. So I think both were like that. The one on the right was taken in Bacchus Heritage Park, which is close to Port Rowan on Lake Erie. And it's, I think, Bortle 4 sky, Bortle 3, 4. I think it's more Bortle 4. Nice place to go and visit and do astrophotography. It's got some nice fields there and sight lines, and not a lot of light pollution, which is good. Both of these used tracking devices, so we'll talk a bit about that. That's the big difference between the previous sessions. We did cover a bit about it, and this session we'll be talking a lot more about camera tracking devices. You'll need them for deep sky photography. Any questions there on those? Okay. All right. So again, this is a bit of a review, but we're talking now about using DSLR cameras, and specifically in this realm, when we're talking about deep sky photography, because we're going to be photographing lots of nebula, which emit hydrogen alpha, we want to have a camera that can take advantage of that. And in order to do that, you'll need a full spectrum modified camera. Or you can still do it and use it, but you're going to get better results with a modified camera. And again, what that is, they remove the IR cut filter on it and basically allow all the spectrum of light to record on the sensor. So was there a question? So what happens is it becomes much more sensitive to emission nebula.
Maybe everyone could mute themselves other than Dennis, obviously.
Okay. Again, the lens, we want a lens that's high quality, wide field anywhere from 50 millimeter, but I'm thinking that even you can go down to something in the 25 millimeter or 35 millimeter for that extra wide field is really handy, up to 300 millimeter. Beyond that, I find that once you get beyond 300 millimeter, it gets a bit tricky to track objects for any reasonable length of time. And then you get into auto guiding and things like that, which is not the intent of this course. So I think 200 millimeters is the upper end of what we can probably manage, depending on the quality of the camera tracker and how well it's aligned. And we'll get into that. Now your integration time is going to go from minutes up to several hours potentially, depending on what you're photographing. So each photograph will probably be in the minute, maximum 2-minute range. Again, depends on the quality of your tracking device, but you're going to take many integrations. So you're going to take many frames, and then you'll be stacking them later on to improve the signal to noise ratio. The only way you're really going to be able to pull that signal out and get a decent image is to increase your signal to noise ratio. And you need to do that. Only way to really do that is with lots of integration time and being in dark skies. So the noise sources you need to be aware of with regards to the type of camera you're using are read noise and other electronic noise from power supplies. That's why I recommend battery use if possible. Temperature, if your temperature is high, if you're photographing in high temperatures, for the evening temperature really high, you're going to have more dark current, which creates noise on your image. So now there's ways to mitigate that, and we'll talk about that later on. Just something to be aware of. And since noise is random, the reason why we want to take several frames is because in each of those frames, the noise is represented a certain way. And after you put them all together, you stack them and average them out, the noise gets averaged out. And so what happens is the signal remains constant, but the noise is random. So it actually ends up being averaged out, and you really improve that signal in the image. So just the reason why you need to do things like that, and that's how it works. As I said before, tracking mount is required. Your subs are going to probably be at minimum a minute long, maybe 30 seconds, but usually a minute long to 2 minutes. And you need to have a fast lens, which we'll talk shortly. So when I say fast, f4 and faster. So anything between, f2 or f1.8 and 4 is advisable. Any questions on that? Okay, when and where to photograph. We talked in previous sessions about location and timing, so just a bit of a review. We want to make sure that we're beyond astronomical twilight, which is where the sun is 18 degrees below the horizon. So for us, it's about an hour and a half after sunset for our specific, around 40 degrees north, or where we are at 43. You're going to wait about an hour and a half after sunset to do this kind of photography. Okay. Let's see, folks joining. And so that's just something to keep in mind, that when you're doing deep sky astrophotography, you absolutely really want to be targeting dark sky and making sure that you're not, and there is no twilight or no sun effect at all. Your Bortle range. So we talked in session, I think, number 2 about Bortle. So from Bortle 1 to 9, 9 being Toronto, downtown Toronto, and 1 being, I don't know, any place on the planet, maybe Chile, in the high desert in Chile or something like that, Atacama Desert, maybe. But for most of us, we're trying to find targets around Bortle 4. So you need to travel a little bit and do some homework. As you recall, there is an online website. If you go to Google, you type in light pollution map, and it'll come up with a interactive map of the world, and you can put your cursor anywhere and it'll tell you the Bortle recording for that zone. So you want to target somewhere around 4. If you can get to 2, that would be awesome, or 3. They're, you know, you don't have to go that far. In a 2 or 3 hour drive, you might be able to get some Bortle 3 sky. So something just to be, you know, aware of. We're not going to be talking about narrowband filters in this course. That's a whole different ballgame. So I'm not going to be covering filters. Yes, you can get some amazing results with the new narrowband filters that are available now, and something to experiment. But that comes with a whole bunch of other things to keep in mind. I wouldn't be attempting wide field astrophotography in Bortle greater than 5. You can try maybe the Orion Nebula and things like that. You might be able to pull out. But the reason for that is you end up with a lot of gradients, which are really, really hard to remove. And you might, like I said, you might get an image and it'll come out, but it's going to be really hard to do processing later on. And I wouldn't attempt it during a waxing, waning gibbous or full moon. So like, you know, crescent moon's fine, not an issue. Or if you plan your photographic session when the moon sets, so there's nice apps for that that you can get online that will tell you when the moon rises and when it sets and what phase the moon is in. So use that in combination with your other apps and you should be good to go. You want to get a relatively flat surface with minimal obstructions. Not always the easiest thing to do, but if you can get into an open field with you know, good horizon views, that's ideal. Not always available, but at minimum you want to have a good clear shot of the north so you can actually polar align on the pole star. That would to me be critical. All right, and then you're probably looking at shooting, depending on what you're shooting and your targets and your conditions, you're probably going to have to go about 20 degrees above just in case there's any kind of residual light pollution that's hanging around. And also that if you're photographing through more atmosphere, it becomes more difficult to improve that signal to noise ratio of your object you're shooting. So again, careful location and planning is needed, especially for deep sky photography. Any questions? Okay, I know there are lots of questions, but you're probably good. We'll have a chance to, there we go. Okay, so we covered a little bit of this before, but just to review, a DSLR camera, full spectrum modification. Some of the cameras have full frame sensors, which is kind of nice, but you don't have to. I mean, you've got a crop sensor, which is, I think, a third smaller. It's fine, not an issue there. The only thing is with a full frame sensor, you get a wider field, but you probably end up having to crop it anyways because of potential aberrations in your optics at the edge of the frame. So some people end up having to crop it. It depends on the lens you're using. You're probably going to need dew heaters. I'm not sure if we talked a bit about this before, but dew heaters are necessary to bring the air around that lens to just above ambient so that it keeps dew off the glass. With short photography, you can probably get away with it for sure. When you're talking about darks, you know, deep sky objects, you're going to need a dew heater. There's lots on the marketplace. I would recommend a 4-inch, minimum 4-inch dew heater. If you can get like 6 or 8, that's a little bit better, but a 4-inch will give you at least most of the diameter of a lens, so that'll cover you off. And with dew heaters, they're typically going to draw about a couple of amps. So you're looking at about 10 watts maybe of power consumption. So if you're using a battery, you just need to keep in mind that these dew heaters are going to draw more current, and therefore you're going to have to just size your battery appropriately if you're using them. Again, fast lenses, f2.8 or 2 to 4 is advisable. It keeps the exposure time down, which is critical for this type of photography. Lots of different lenses out there. these are the two I've used, Canon L series and the Ascar. And the reason why I like the Ascar, it's actually featured at the bottom there, and I'm sorry for the small print there, but let me just walk you through why this, I think, lens is good for us. It's designed for astrophotography. And the reason for that is got a very fine focus and coarse, so you can adjust with a coarse focus, and then it's got a fine focus, which has a lot of gradation steps in it, so that some of the lenses you have are often difficult to focus on stars because they're so touchy. Ascar is not like that. They give you a lot of room to be able to move the focusing ring so that you can come to precise focus. And then there's little knobs where you can lock the focus in. So if you bump it or if something happens, you won't lose focus. Really handy. The other thing too is it has FPL 53 glass, which means even at the edges, you're going to get sharp stars and a minimal chromatic aberration. So all the light comes to different wavelengths of light come to a common focus. So you don't get a lot of color fringing and things like that, which is a problem with a lot of lenses, especially when you're dealing with deep sky astrophotography. It really comes to play, or even, planetary for that matter. Has a 48 millimeter T-ring, so it easily adapts to many types of adapters for cameras. It's pretty well universal, and it has a nice dovetail plate on the bottom, so you can actually attach it to a lot of mounts. Nice dew shield on it. It's long, so that if you forget your dew heater, or for whatever reason you don't have one, it can withstand a fair bit before it dews up. The picture at the top is a star tracker. So that's a guiding mechanism, and that one is the Ioptron SkyGuider Pro. There are many. Skywatcher has a whole family of them, and there are other manufacturers that build, these star trackers. So what they do is they compensate for the rotation of the Earth, and they give you motion in the right ascension. They do not move or they do not track in declination. So the important thing to keep in mind is that it's portable, it's fully adjustable, it's relatively lightweight, it's a built-in battery, and some of these batteries will last 15 hours. So they're really quite good. And some come with a counterweight. Why that's important is because if you put your lens, if you're using a telephoto lens with your camera, you might exceed the the weight balance capability of that mount without a counterweight. So some come with these counterweights you can put up to, I think mine will take up to 8 pounds, which is quite significant. So, and it gives you a lot of options. They also come with a dovetail plate, so you can, mount the camera right on there and the dovetail plate, and then they come with adjustment knobs, clutches. Some come with polar alignment scopes, and I'll show you what that looks like in detail later on. But the polar alignment scope is really a great tool so that you can quickly polar align to the North Star for your time, date, and location. And once you have your polar alignment dialed in, your star guiding accuracy will be quite good. So that's a bit about the mount. And again, you want to have a solid steel or metal tripod, something that's got some good weight to it. It's going to not move around, especially in a little bit of wind. And you don't want those vibrations. Weather apps. So we'll talk about all these things a bit later on. Portable battery, and of course, Sky Atlas to find objects. The camera there shows a Canon camera with a sensor. So there are many different kinds of cameras. I just wanted a picture of a DSLR. Okay, so we talked about polar alignment. This is when you're setting up and you're choosing a location. You want to make sure that you have a clear visibility of the North Star. I'm not going to tell you where the North Star is. You already know that. But for each of these tracking mounts, and most of them, I think probably all of them, you're going to need to be able to find a way to align your mount on where the target is for your location, the time, and the type of mount you have. So in this one, you can see this app. This is an app that I think you can get it on iOS and Android. And you can see this little dot here. Well, that dot indicates where you need to adjust your Alt-Az adjustments for your tracking mount so that you can see that star in the center of your or position on the reticle in your mount where that pole star should be. So you align the pole star to fit that little dot there. And this is already set up. This will pull information from your phone. So it'll pull in your precise location, your latitude and longitude, your elevation, and the time. And with that, it'll calculate the precise location of where the pole star needs to be. So you just line it up with your Alt-Az adjustments. Don't move your mount. Don't touch it, and you're good to go for the evening. So it really makes it's essential if you're going to be doing this kind of photography. Are there any questions on this? And one of the things I'm hoping to show for next Friday is kind of like what it looks like and how it works. So if you have more questions, you can think about them. We can review some stuff next Friday before the potpourri. Good. Okay. God, you guys are really know anything. Okay. So settings. These are camera settings, which are going to be specific to deep sky photography. So obviously you're going to be shooting in manual mode only. So put on M. You wouldn't believe how many times I put it on A and can't figure out what's going on. I can't adjust anything. You know, remember it's dark. So you need to practice this stuff in advance and not figure out this stuff when you get out there because you're going to get confused. But I always wear a headlamp, red headlamp, when I'm out, because invariably I messed up a setting or I got to check on something, and you know, if you can't see, then and you don't want to use a white light because you use a white light, then your night vision's gone, and you know you got to wait a little while. So, anyways, I recommend like a red flashlight or a red headlamp so you can keep your hands free to work on your equipment. You're going to be shooting in RAW, so no data compression. You're getting all the information that your camera can take in without being processed anyway. Your ISO settings on your camera are going to be anywhere from 800 to 3200. That seems to be a bit of the sweet zone. Anything beyond that, you're going to get more grain on the image and you're going to lose a lot of dynamic range. I typically photograph at 800 because I want to have the maximum, and it's my camera too. Some cameras are a lot better than others in terms of how much they can, what they do for the amplification and dynamic range for higher ISO. Is better electronics. My particular camera, and to have to back it down a bit. Okay, so I'm saying here, do not use your lens wide open, but if you have a lens which is slower, in other words, a F ratio which is beyond 5 or 6, if you stop it down, it's going to be way too long a focal ratio, and you're not going to get much recorded on that sensor for the time you take that shot for. So if you have a really good lens, you might be able to get away with not stopping down the lens. I find the ASCAR I can keep wide open and makes no difference. So, but not all lenses are like that. You need to experiment with your lens and see what works. You know, just one f-stop, just so you know, one f-stop is doubling the exposure length. So it's a massive difference in terms of how much light is actually being recorded on your sensor. You're going to use an intervalometer because there's no way you want to touch your setup. If you bump that camera and the tripod, you may have to polar align again, stop what you're doing and go back and do another alignment. So if you can use a remote intervalometer, Bluetooth or Wi-Fi, the better. Mine is old. My T3i is older, so I have a cable. But, you know, if you can have all your, so you have your objects that you want to photograph, and I would probably stick to one, maybe two a night, probably just one to get going. You're going to have in advance, you're going to calculate the length of the exposure. So each exposure, you're going to know the length and how many exposures you're going to take. And then you need to program a delay in between each of the exposures. And so the length of the exposure is going to be based on the object you're photographing and the quality of your star tracker. So I pointed out earlier on that at minimum, you're probably talking about a minute to two. With 2 minutes on f4 or faster, you're going to record quite a bit of light. So you probably don't have to go longer than that. And in fact, you don't want to, because you're going to have star trails. Your star tracker probably isn't good enough to be able to do that. So a minute and a minute and a half, you can actually record quite a bit, especially if you start taking a lot of exposures. So that kind of like would be the target. For example, you can photograph the Horsehead Nebula, which is quite dim, with a minute and a half exposure and record something on f4, no problem. So then it's a matter of the number of exposures you're taking. Depending on the object, so if you're shooting, say, the North American Nebula, which is dim, but it's still on the bright side of dim, if it makes sense, you're probably looking at about, with an f4 lens, you're probably going to look at a minimum of 40, if not 60 or more exposures. If you're going for something dimmer than that, then you're going to be spending a lot of time. There's going to be quite a few exposures required to increase that signal to noise. And every camera is different. So this is where a ton of experimentation comes in. And this is where deep sky astrophotography takes a lot of time to really get some results from. It's probably one of the most frustrating forms of astrophotography, because everything's a bit of a trial until you can get it. You can only process so much afterwards. If you don't have enough data, there is no processing program that'll make up for that difference. So that goes back to how many objects you're going to photograph in a night, how much time it takes you, what object you're photographing. So if you think about this, and I know I'm spending a lot of time on this, but this is really critical. If you're, you know, the time to figure out what object you're photographing is before you go out. You look at on there the kind of like, how dim is this object? Where is it in the sky? And work out a table which gives you this information. You know, length of exposure and number of exposures. And then program a delay in between them. And the reason for the delay is you want to minimize any vibrations in between the shots. Also, there is a element of noise that gets, the more exposures you take in rapid sequence, the more noise that's generated by your camera, because it heats up. The short delays actually help. And this is not, you can go online and do some research, but this is stuff that I found from experience, is that you program a short delay and it helps settle everything, including electronics, and you minimize the noise. It's another trick. If you have a full spectrum camera, keep in mind the colors are going to look weird potentially. So you're going to have to do some color calibration in advance of photographing. Make sure that you have a gray card recorded in your custom white balance in your camera. Because if you don't, you're going to have to process them, and could be difficult processing the color properly. So there is a whole process behind that. We can talk about it perhaps next week, but essentially what it is you're going to get a gray card. It has to be a certain kind of gray card, so I can send you guys some examples. And then you're going to photograph that gray card in proper lighting. And then you record that in your custom white balance setting for your camera. So every time your camera takes a photograph, it references that calibration, and it then calibrates the color. And it works really well. So otherwise, you're going to get some really weird hue colors depending on the objects you're photographing. Any questions on that? I know there's a lot of stuff, and there's a lot to take in. But if you have questions, and afterwards, if you have questions, by all means, please ask.
Actually, I have a quick question about the gray card thing.
Yeah.
Is the gray card thing, you just do it once with the camera and then you're done? You don't have to do it every time you shoot an
Nope.
astrophotography shoot, right?
Nope, that's right. You got it. So you
Okay.
do it once and it's stored in your custom white balance settings. If for some reason you lose that setting or erase it or whatever, for example, you'll have to do it again. But yeah, it's only once. Thank goodness. Good question.
I got one question. You talked
Yeah.
about waiting between shots, since we're interrupted anyway, waiting between shots to minimize the vibration from shutter and everything. You're thinking 2 to 3 seconds,
Yeah.
okay?
No more than that.
And you don't ever consider leaving it longer to let the sensor cool down in between to reduce noise, or no?
No, that's fine, Alan.
Okay.
It's a matter of getting all the electronics processing what they're processing. Some cameras actually require a bit of time to record the image and process it. So
Yep.
that's another reason for the delay in there. And again, if you're going to longer exposures with a camera, then it's a whole different setup anyways. So it's not like these exposures are that long, but it helps to get if you're having a high resolution camera and you have an older one in particular, sometimes it takes about a half a second or more for the image to actually record. So you don't want to mess it up. So I just program a short delay in there for those reasons. Yeah.
Cool. Thanks.
Yeah, cool.
Dennis, if I can just jump in and say
Yeah.
something.
Yes.
Also, the type of card that you use, some cards record a lot faster than others.
Yes.
So the pro rated cards will record a lot quicker, and they can record like the information faster. So you don't need that extra couple of seconds, but it is always good, especially if you have camera shake. The other thing is some of the newer cameras with that are mirrorless are a lot better at doing
Yeah.
this than
Yeah.
the previous ones that have the full shutter and everything. That's
For
all.
sure, the newer cameras have less read noise. They're a
Yes.
lot faster, they're better processors.
Yeah.
And you may be able to get away with, again, it depends on the type of camera you have and things like that. So, and the sensor, they're getting better for sure.
Yeah, with everything else, I would try, like I always test something out first, and then
Yeah.
if it works, then it works. That's all.
Yeah. Good point, Jake. Okay. So we talked a bit about this. I'm not gonna, we talked about location and how long is an object visible. That's the other thing too. If you're looking at what object you're going to be photographing, you'll want to know how long you're going to be spending on an object and how long is it visible for. Because if you have an object that starts to set after half an hour, you may not have recorded enough data. And it just happens to be where it is. And you'll find that in the summertime, if you're shooting objects in Sagittarius or Scorpius, and it's fairly low on the horizon, you're going to run into this. So again, depending on where your location is, so just keep that in mind. And again, it doesn't necessarily have to be on the horizon. If it gets too close to the horizon, you get effects from you're going through a lot more atmosphere. So there's distortion effects there. There's also another effect which is caused by heat reflecting off objects, off of concrete and off of other things, and it messes up your photograph. So you want to keep higher up. I would say try to keep 20 degrees. And so if you're shooting Sagittarius and Scorpius, you may be below that. So you only have a certain amount of time on there. Something just to keep in mind with how you're planning your photographs and where you are. If you're shooting over water, versus buildings and things like that, you're probably going to have a little bit more leeway in terms of how low you can and how long you can photograph for. And I would avoid photographing too many objects, especially, with the limited time you have. The key is to get data. So, and for information, if, for example, you're taking 20 shots of 20 or 31 minute frames, in order to improve that signal to noise ratio, you know, double it, you need to lengthen the exposure time by 4. So adding a few more frames won't do anything. Even doubling it won't do much. You got to go 4 times to make a considerable improvement on that image. That's how the math works. So that's what I'm saying is when you're photographing it, you really got to look at how many integrations am I going to have to, how many frames am I going to have to shoot here? And, you know, if you can't get them all in, if you're thinking I'll get one or more and, you know, pushing the boundaries a bit, it's not going to do much anyways. So just something to keep in mind. Okay, so focusing. On the last session, I think, or session 2, we started introducing focusing. So this is a bit of a review. 2 methods of focusing. And, you know, the one that most of you will probably be familiar with or use is that you'll have a viewfinder on your DSLR. Most cameras will have them. You're going to go in live view. And you're going to center on at least a medium brightness star, not something too bright. If you try to focus on something too bright, you will not get, it'll be very hard to get a proper focus. So something of medium brightness, even a little bit lower, and something higher up. So a bit more than 30 degrees in elevation from where you are. Center that in the viewfinder and go to maximum zoom on your camera, and then slowly adjust your the focus on your lens until you get as tight a star as possible. Once you achieve that, then you're going to want to take several 1 to 2 second test photos. Go back, zoom in on that picture as much as you can to see if it's in focus or not. You'll be able to tell because it won't be a tight dot on there. And then lock the focus if you can. That's important because, you know, these lenses, some of them have a tendency to move in you know, and we're talking about a difference of a very, very fine movement on that focusing ring for your camera will make all the difference. And one thing about this kind of photography is the focus is off. You can tell right away. It just doesn't look right at all. So that's where you need to want to practice this at home before you get out there and find out how your lens and camera work with regards to focusing. And it could take a long time to focus. So, you know, be patient and persevere with that. Any questions on that technique? I know I went through it quickly, but it's a bit of a review. The other method, which is a little bit more foolproof and better, is using a batten-off mask. And as you recall, batten-off mask is only relevant when we're talking about shooting anything deep sky, so where there's stars involved. The batten-off mask, you can see it there in the upper right, looks something like that. You'll order one and it'll come with adjustments so you can fit it over the top of your lens. And then what you're going to do is you're going to follow the techniques that I talked about before. You're going to center on a medium bright star, place the mask on, and start adjusting the focus. And what you're looking for is a convergence of those lines. So you can see here, you don't quite have the proper convergence points for these lines, are a bit off. You want to go for this so you can have proper convergence, and that'll really tell you that your star is precisely focused. Then you want to lock the focus and remove the mask. What you might find is that if you're using a lot of these kit lenses and some wide angle lenses, is that the focusing ring is at the extreme end of the lens. So when you put the mask on, focus it, and you take it off, there's a good chance you're out of focus. That's a very common problem. So when you're looking for the right kind of lens, just keep that in mind that you want to have at least a large enough dew shield. So that gives you the distance between the mask and your focusing ring is a certain distance. And if you can, you get a lens that you can lock the focus in place somehow, because it will move. But this is probably the best method there is to achieving as perfect focus as possible. Any questions on that? Okay. Okay, finding objects. Again, this comes back to you know, understanding the night sky, the constellations, the marker stars, and using your sky atlas, whether it's, you know, a paper version or in your laptop. But honestly, at the end of the day, if you start this hobby and you spend time looking at sky atlases and using binoculars, knowing where these objects are, it's going to make this whole process go a lot easy. Finding and framing your objects when you can't see them in your camera is tricky. So you got to look at, you know, your marker stars and where the stars are. I'm not talking about using go-to mounts here with you know, plate solving and all that kind of stuff. That's, you know, that's for other sessions. But when you're out there and all you got is a sky atlas and your star tracker and your camera, you'll be amazed how difficult it is actually identifying where that object is and precisely framing it. So that app that I showed you earlier on, that's the Polar Alignment Pro, it actually has an object finding feature in it, which is and there's several steps to it, but it actually can work pretty good if you have it properly polar aligned. Anyway, so this is going to be this and focusing are going to take most of your time to perfect before you can really get into doing deep sky astrophotography. One technique that works in terms of framing is if you have a good program, planetary program, or a star atlas, you take 5-second test photos and get a field of view of the stars, and then you match those stars for what you see in your sky atlas, and you know you're in the right area. Any questions on this? Okay. All right. So now you've got all that done. You figured out. Then you're ready to start taking your first photographs. You got your setup, it's complete. Your tracking mount is turned on and it's set for Northern Hemisphere. If you're in the Northern Hemisphere, your devices are powered, including your camera and your dew heater. You have the object framed and focused. Your intervalometer settings are programmed. You take 2 or 3 test photos and you make sure that the star fields are correct. I can't tell you how many times I've taken photographs thinking that I was on target and I wasn't. And, you know, you burn up an hour taking photographs and you realize, you know, and use some words that, you know, some of our politicians might use when they get booted out. Afterwards, finding out that, you know, you're actually photographing something completely different. And there goes your night. It's not uncommon. So anyways, this is something that, so the first part here, you really got to take your time and try to nail that down properly. And if you make a mistake, that's what happens here. Excuse me, I'm just going to turn my light on. So here's some guides here that I put together. So we talked a bit about before. I'll just give you an example of f2.8, a 30-second photograph with a lens of f2.8 will capture North American nebula. So you'd be surprised what you can actually capture between 30 seconds and 1 minute if you have a fast enough lens. At f4, that's going to double. So the next stop, it's going to double your exposure settings. And then if you get to f6, 5, 6, or f6, now you're looking at probably more time than your camera tracker can accept. You'll start getting star trails and it just won't look right. So I would say that you need to keep within this, F2.8 and F4 range for any kind of meaningful deep sky. And I would try for a minimum of 1 hour integration, if possible, and try for more if you can, depending on, again, what object you're shooting and where it is in the sky and those kinds of things, your setup. And it takes a lot of practice. So, but like when you get the hang of this and you start getting results, it'll blow you away. And even if your first results are, terrible compared to what some others are doing, don't look at it that way. You've just recorded an object that's could be thousands of light years away, and you did it. And there's a real sense of accomplishment when you get to that stage. Then it becomes addictive, and then your bank account suffers. So that's just a bit of warning. Right, Jake? Oh, geez, but it's true. Anyway, so now that we've taken our first photographs, we have to look at what's called calibration frames. When you take these kinds of photographs and you look at them, they may not be what you expect. There may be all kinds of light gradations on the image. There is going to be some stuff that looks like dust specks or noise, unevenly illuminated fields, all kinds of things. So we need to do what's called taking calibration frames. So, what are they? Well, there's actually 3 types. But the 2 I'm going to talk about here are to compensate for dark current and read noise. So if you were to cover the lens of your camera, or cover your lens and take a photograph, say a 2-minute photograph, and you look at that image, it's going to show a lot of little specks on there. And those specks are what the camera is generating. It's the noise that's generating the camera. That's also in your picture that you photograph, but you just don't see it because you're looking at the stars and the image. We got to find a way to remove those. So that's called dark frames. And the other thing that's going to be present on your image is that you might see areas, rings, or large dots of dark spots or darker spots, and spots in areas of the picture where there's more background light and others where there isn't any background light. So what you need to do is take a calibration frame, and that's called a flat field. So it corrects, it's amazing how well it works, but it corrects for dust on your lens, and every lens and every system has dust. I haven't seen one that isn't. And unevenly illuminated fields, pretty well every image you take is going to have that unless you're in Portal 1 sky. So how do you take a dark frame? Very easy. And I do this at the conclusion of every session, where you place a lens cap on the lens, and you will take the same exposure with that lens cap on as you did for your imaging. So if it was a minute-long exposure, you will take a minute-long exposure with that lens cap on, and you're going to take, say you took 40 frames, you're going to take a minimum of 10 dark frames. So ratio 1:4. Because your dark frames are also going to be averaged with that noise when it removes it. So there's a little bit of added complexity to it, but that's why they come up with that kind of ratio. So that's pretty easy. You got that figured out. It's you're gonna have to do that with every time you go out and take photographs. There's no way of getting around it unless you have a camera that has got 0 noise, and I haven't found one yet. Anyway, some of the new astrophotography cameras, the dedicated astrophotography cameras, they're so good that they don't have so little read noise it's not required anymore, but that's not my case anyways. So any questions on dark frames? Okay, so what happens is with a dark frame is that when it comes to doing your processing afterwards, there are programs that you're going to be using that'll automatically subtract the dark frame from your original subs or exposures, and that removes all those noise, those little specks of noise in there. Okay, so there's a lot of programs out that'll do that. Deep Sky Stacker is a good one, and it's free. PixInsight is another one. It's a pay-for one, but it's an excellent program for calibration. I'm not going to get into those programs. It's a whole different thing. But when you get into dark, deep sky object photography, you're gonna need to be working with various software to do your calibration at minimum. Flat fields. So this is what I was talking about before in terms of flat field. It looks pretty awful, but this is the result of a dust that's on your lens or somewhere in the optical train. It blocks a certain amount of light, and those sensors are so sensitive that they will pick up this and show it as a shadow. So you're going to have a bunch of those on. You can see some vignetting here. So in other words, your field isn't fully illuminated on your sensor, right? So we need to do correct for all that. Here's one here. These are donuts, and donuts will happen on lenses or telescopes, for that matter, that have mirrors and a central obstruction. So Schmidt-Cassegrain, Ritchie-Chrétien, Maksutov, even Newtonian, instead of being here, so this is a refractor, they're going to create donuts here. So we got to find a way to get rid of those. How we do that, there's many methods, but the easiest one is if you have a dew heater, which is great. If you do have one that goes around your whole lens, you place a white t-shirt or something white, and it goes over the objective of your lens. And then what you'll do is in the dusk sky, you're going to point the telescope at an evenly illuminated part of the sky, and you're going to take a series of exposures. But what you're going to do is you're going to take an exposure, or if you have live view, even better, because it's recording the light that's coming through, and then you're going to adjust the exposure lengths until your histogram is half scale. Okay, I threw a lot of things in there. I apologize. But in every camera, in most cameras, you have a button that'll give you an indication as to how many pixels in your camera have a certain percentage of illumination, and it represents it in the chart. So it'll look like, I think I have one down at the bottom here. So this is a little histogram. So you'll see most of the light is captured within a certain range. And what you want to do is you want to set the exposure so this bump here occurs in the halfway scale of your histogram. So that means you're getting the proper illumination on that sensor, and you're going to have to play around with that. So sometimes you can do it by eye. You adjust the exposure length, and you'll see that the image gets darker or brighter. But you want to get to the point where you can actually see something like this on your live view. And if you see something like that, or where you have the unevenness of light and the shadows created by dust, take several frames of that. Your ratio is going to be probably about half to a third of the frames that you take for your image. Half of those will need to be flat fields. Because again, what happens with flat fields in your calibration software is it averages them all out so that you get the proper image calibration. I know I went through that quickly. It's a technique that takes time, and there are many ways to do it. what I'm trying to give you is probably the simplest way. Some setups now that are a little bit more sophisticated will do this automatically. And there is a easy way to do it with a light panel. And I'll show you that in a little bit. Any questions on this piece? I know I went through it quickly. It takes time to practice it, but it's essential if you're going to be doing deep sky photography. Okay. There are no questions, and I didn't do a good job. I'll come back to it. Okay, here's the flat field. Here are some devices that you can use to make calibration frames in flat field a lot easier. So these are light panels. I've actually made, this is one here I made myself. It's a light box, and it goes over my refractor. So it's felt line, and it'll sit, slides onto the refractor, and then it's already set with the right level of illumination, so that I don't have to worry about the brightness levels. It's set already based on the electronics I have in the back. I made this, and then you just take probably 1 second photographs, do it 20, 30, 40 times, however you need, depending on how many subs you've taken, and then you record those flat fields. This is another one. This is a light panel from Michaels, costs $15. It's adjustable, and basically I covered it with opaque drawing paper, several layers, so that it's very even. The light is very even. Plop that on top of the telescope like this, turn it on, take a bunch of photographs, and you're good to go. Sometimes this can be a lot easier than finding that perfect spot in the sky with even illumination and putting a t-shirt over the top. Whatever it is, there's many different ways of doing it. Any questions on this? Wow, okay. I mentioned before about calibration software. So there's a few that are free online. Deep Sky Stacker is one that's very popular, and it's relatively easy to use. It will ask for the subs that you took of the actual object. It'll ask for the dark frames. It'll ask for flat fields. And then it'll ask for something called bias frames. But I'm going to stay away from bias frames right now. That's more relevant for different kinds of cameras, and I wouldn't worry about it at this time. So you'd stick to just dark frames now and flat fields. And then what happens is this software will look at your image, and it'll look at the stars there, and it'll start aligning the stars. It will automatically subtract the dark frames from your subs, and it'll do an average calculation of flat field with your subs, and it'll remove all those artifacts, and it'll align the images. And what comes out is a image that looks very different than your individual subs, because what you've done now is increased dramatically the signal and reduce the noise. And you'll be amazed at what actually comes out the other end. We might, in future programs, whatever, we might have some workshops on this just to get people, especially if you start doing photography and you need help with the software part of it, a calibration, you can reach out to me. I'll give whatever help I can on that, because it's going to take time. Any questions on this? How are we doing for time? Okay, we're at an hour, I think. The last one more chart. So this is a photograph that I took with a 200 millimeter f4 lens north of Port Rowan, and this is Roa-Fikiu, which is a nice area of sky because it's got a bunch of different colors and molecular clouds. I call this actually the clown nebula, because actually you have a clown space in the middle here if you look at it carefully. That's what I call them, the colors. But anyway, so this was done with a star tracker I believe 2-minute exposures times 60. And the sky condition wasn't too dark. It was Bortle, well, dark enough, Bortle 4 at ISO 800. So that's kind of like the results. And again, using Deep Sky Stacker to stack all those images, taking dark frames and flat fields. So.
Did you have a filter on your camera for that, or is
No.
that just the straight camera?
No, that's just, yeah. I have a modified camera, so I don't have any IR filter in a way. It's
Right.
just, but yeah, that's it. That's without any filters.
That's cool.
So that's 60 2-minute exposures,
Yeah.
and then probably something like 15 or so darks.
Yeah.
And a few.
Probably about 20 flat fields.
20 flats. Okay, cool.
Give you an idea.
And processing time, any idea? How long did you use Deep Sky
Deep
Stacker?
Sky Stacker to do most of it, but actually, honestly, processing, if you have enough data to work with, and the signal to noise ratio is okay, it won't take you that long. And I didn't monkey around with this one a lot, tell you the truth. I could probably do a lot more to bring out some more dust, but I just didn't. And sometimes there are quite significant advanced techniques that people use to bring out the background dust. So this image, I mean, if you'll see there's dust here at the top, a little bit of dust showing up, but you know, if I spend a lot more time in it, half of this image will have all this brown dust all over the place. It'll look quite a bit different, but it depends on, this is where, you know, you get into image processing and it's a personal thing, what you like, you know, what kind of results you end up with and stuff like that. But yeah, but this is 200 millimeters. So this is just on a SkyGuider Pro and stuff like that. So nothing terribly expensive or, you know, involved. Okay, so that's it for the course. We're going to be, again, stay tuned for an announcement on a follow-up. But does anybody have any questions on anything I presented? It doesn't have to be this session, it could be on anything in astrophotography. Anybody? Cool.
Just one. I
Yes.
think the biggest challenge for me is just knowing what to shop for. I don't have much to go off of right now, right? But I guess that's part of research, talking to people. And I mean, this photo is taken by Canon T3i, so that's pretty good. And then it comes down to the lens you have, right?
Yeah, I would say that, I mean, a T3i is an old camera. Okay, so it's many years old. I mean, you can, and this is the kind of results you can get. I just haven't upgraded my DSLR. I use different cameras now, but a lot of the cameras you're going to find now are even better than that. But there's a lot of expensive cameras that aren't good. And so if you want, just reach out to me or go online. There's a lot of forums that will actually rank these cameras and tell you which ones are better than others. But I tried to provide you some attributes that you need to look for in a camera, and also the kind of lenses and what you want to look for in a lens in terms of matching it up. And again, there's a lot of great resources online, but you know, tried to cover off the things that you want to look for. So you know, for a camera, you want to have a, you know, decent crop or full frame. It doesn't have to have all the huge number of bells and whistles, but there are certain functions that it needs to have. Mirror lockup is a good one, you know, but also the ability to program, if you can get an intervalometer in there. One that's, again, looking at the type of sensor on there, and you know, can you modify it? Is it possible to modify? Can you get one that's modified? There's people out there that offer modified cameras at reasonable prices, and they're maybe a little bit older, but they're excellent for astrophotography. I use this camera only for astrophotography because it's been modified, and I got it from a guy in Montreal. And so there's a lot of resources online you can look up. Yeah, and then with regards to lenses, something that's fast, and not a kit lens. I would avoid kit lenses because unless you're doing really wide field photography, but something that stick to more the there are good zoom lenses. This Ascar is telephoto. So F4 or faster is what you want to stick to, and something with really good glass, like I covered earlier. So tried to cover off the manufacturers that I'm familiar with, but by all means, those aren't the only ones. There's many good ones out there. I don't know if that answered your question, Mike, but you can reach out to me and I can help you out individually if you want.
Guys, I appreciate that. Thank you very much.
You're welcome. Anybody else?
So, you'd mentioned about another potential session, but did I hear you say something about at the next potpourri, you might be available before we start that?
Yeah. So one of the things I'm talking to Swapna about is getting a session, maybe half an hour to probably an hour before the potpourri, so something around 7 p.m.
I can interject here
Yeah.
because there were emails going around during this session.
Okay.
Where I think Swapna is on here. Yeah.
Yeah, I'm here. Yeah.
And we don't see an issue with doing it. The only issue that I have thought of is that I arrived early for our last potpourri or our last speaker night, and the room was locked. So it only took probably 5 minutes to get it unlocked. But we want, so if we're planning on showing up for 7, we do technically have the room from 7 on. 7 to 11, I think. But there could be a slight delay getting in. But it's UTM room 370. It's the UTM room. It's on the third
It's
floor.
the one that
like
we were
last
in
time.
last time, 3140.
Yeah, it is. So
Okay.
I just sent you a note, Dennis. I can coordinate with you. Yeah, room's not an issue. We should wrap up by 7:55 just to get the potpourri going.
Sounds good.
We'll use the back of the room, so the same room as the meeting that occurred last time.
Okay.
So it'll be so what we're thinking is if I can meet you at 6:45, we'll make sure the room's unlocked.
Okay.
People can arrive by 7, but then we wrap up by 7:55, and we use the back of the room so that we don't interfere with, especially Alan and Rob have a lot of work to do.
Yeah, for
And
setup.
and I also will
sure.
have to probably exit yours. So this 7 to 7:55 is open to your students only, Dennis.
Okay. Perfect. So I will
If that
send an
works for
email out.
you.
All right, that works fine for me. So I'll send out an email with the details and to the members, and we'll deal that way. Okay, thanks for setting that up.
Yeah,
Well,
no problem.
appreciate it.
Yeah,
All right.
great.
Okay, everybody, thank you so much for being so patient and listening in. I hope this series was useful to you and beneficial, and I wish you all the best and good luck in your attempts in astrophotography. And I would love to see what results you get. Doesn't matter what they are. And if I can help out in any way, just reach out to me.
Dennis,
Yes.
a huge thank you for all the work you put into that. You put in, well, I have some idea of what kind of work you must have put in. Excellent job. And it's nice that we've got a resource now on to start people on this very expensive journey.
Yeah, it could be very rewarding. I know you start getting into the hobby and you do observing and things like that, and before you know it, you want to start taking pictures. And I know all the mistakes I did years and years ago getting in. It took a long time to iron these things out by trial and error because there wasn't a lot of resources. It's a lot better now, and I wish I had somebody that could have guided me, that took the time and helped me learn, because it would have been a lot easier and less frustration. But if I can help out in any way, I will.